Production is broken. Marketing or ops made a mistake, and now you have thousands of database records in a corrupted state. You might panic and start running manual queries to fix things up, hoping they don't make things worse. I treat issues like these through a protocol. Here's my framework for turning chaos into process, and even more important, sleeping well at night. We've all been there. A feature flag was flipped too early, a data migration didn't account for an edge case, and now production data is wrong. And you need to write a script to fix it. Fast. When you're in this situation, the temptation is to write a quick and dirty script, or even worse, to copy-paste whatever solution your AI assistant spits out because it only needs to run once. And that, my friends, is a lie. It only needs to run once. That's a lie. And why? The script may run halfway through and maybe it crashes, or it works, but triggers a side effect that you didn't think about. Or it succeeds today, and 2 months down the line, you're debugging a cascading failure that started with that quick fix. Recently, I dealt with a limited edition product that was mistakenly released ahead of schedule. These triggered several downstream automations that made it appear on a couple of thousand orders. If we had rushed a one-off script, we could have duplicated shipments, desynced inventory across warehouses, and thrown off revenue forecasting for the entire quarter. Never underestimate what seems like a small issue. An early release ripples through organizations, vendors, partners, suppliers. Small mistakes do compound. But, using the framework I'm about to show you, we fixed a few thousand orders with zero downtime and zero data lost. 4 edge cases got flagged for manual review, but everything else fixed. If you want more production engineering content like this, hit subscribe, it helps the channel grow. Here are the 5 principles I use for every operational script, plus a bonus one at the end that isn't about code. First rule, never let your script or your AI guess what it needs to fix via query. Let's picture this. You may write a SQL query such as select ID from orders where completed at greater than the date of the incident. Seems reasonable enough. You test it in staging and it's fine. But between your test and the production run, 2 hours pass. Orders keeps coming in. That 2 days ago now includes orders that aren't corrupted. The inexperienced version of me would have run that script without thinking twice. And what happens then? You may process 300 valid orders that don't need fixing in the first place. Best case scenario, you only waste some time. Worst case, some trigger refunds, some trigger inventory adjustments. Customer support staff gets an email. Hey, what did my order just cancel? Queries like those are moving targets. Run it now, you get one result. Run it 10 minutes later, different result. Instead, define your scope statically. Before you write a single line of code, get a CSV or a list of exact IDs. You can get them from ops, from the data team. You can run your query and save the list of IDs, but keep the scope fixed. Your script will iterate over that frozen list. If something goes wrong, you have a hard upper limit on the blast radius. You can't accidentally process more than what's in that file. Principle 2. Just because an ID is in your list doesn't mean it's safe to touch. Time moves between when the list was generated and when you actually run the script. Maybe the order was already shipped. If you modify it now, you might desync the warehouse system and trigger a duplicate shipment. Or worse, the shipment goes out and your system says it didn't. Now a real physical packaging is wandering the earth with no digital record. We don't want wandering packages, do we? Here's the question you need to ask domain experts before writing anything. If I update a record in this specific state, what happens because of this? Because your AI assistant has no idea. It doesn't directly know that updating an order in the fulfilled status makes it to be automatically picked up by the warehouse system. It doesn't know that records from 2019 have a null column that modern code expects to be populated. It will happily generate code that looks perfect and crashes on record 237. So my scripts always start by splitting the input into 2 buckets mostly, the fixable and the unfixable ones. Safe records get processed, risky records get logged and headed back to humans with a note, such as these are too complex, handle them manually, of course if it's possible. You won't fix everything, and that's fine, because fixing 90% of the items safely is always better than attempting to save 100% and in the process breaking 10%. This is my favorite. This is the principle that separates scripts that fix things from scripts that multiply disasters. Scripts fail as everything. APIs time out, your database connection drops, your Wi-Fi hiccups, your laptop battery dies. If your script crashes halfway through order 500 and you run it again, what happens? Your script must be idempotent. That means that if you run it multiple times, it has the same effects that running it once. Instead of refund disorder, your logic must be ensure disorder is refunded. You need to handle cases where the state changes. If it's already refunded, do nothing, move on. Here is where it gets really tricky. During repair scripts, an order might appear cleanly refunded because the database says so, but the incident is exactly about wrongly refunded orders. AI tools might use the code-based tools to tell orders apart, but in this script you need to provide the temporary definition of correctly refunded. Before you run anything in production, ask yourself, can I run this 10 times and get the same result? If the answer is no, you're not done writing it. Principle 4. You need receipts. 3 days after you run the script, someone will ask, of course, did we fix order 3047 blah blah blah, or customer support will need the list of every affected customer because of the influx of customer support tickets, or legal will want to know exactly what data you touched during an audit. You cannot be grabbing through your terminal history at that point. What happens if you close the terminal window? Because you did? Of course. Every operational script should generate a detailed report. The format is not really important, a CSV, a JSON file, a structured log. Pick what fits your situation, but at a minimum for every run, at least log what you processed, what succeeded, what you skipped and why, especially, what failed and why, and timestamps for everything. The more information, the better. You never know what little detail will be needed down the line. For example, my scripts generate a structured log file per run in a way that's easy for humans and machines to read. I attach this file to the postmortem ticket and call it a day. Then I sleep well because I know I can answer any question that might come up later. Want to know what happened to order 58? Grab for it. How long it took from first run to complete resolution? Check first and last timestamps. Easy. Final principle. Build in a way to chicken out. Destructive actions are dangerous, of course. Deleting records, issuing refunds, modifying inventory. These are one-way doors. I always implement a dry run flag that defaults to true usually, and when it's on, the script logs exactly what it would do, but touches nothing. I do the test run, I read every log line, I check that the would update messages make sense, and only when I'm 100% certain, I flip the switch and let it go. Dry runs add complexity to the script, but it's worth for the confidence it builds in the logic flow. Those were the 5 technical principles, but here is the bonus one that saves and builds, most importantly, your reputation. Production incidents are only in part about code, the other part managing human anxiety. If you want to remember one thing from this video, and just one, remember this. When you go silent for 2 hours, you're not just writing a script, you're letting everyone else's stress compound. They start imagining worst-case scenarios, they start escalating, someone pings your manager pings you, and now you're context switching while trying to debug edge case number 3. The solution is stupidly simple. Over-communicate, please. Every 15-20 minutes or at any major milestone you reach, drop an update in the incident channel. It doesn't need to be profound or deep. You might say, still investigating scope, found 2,000 affected orders so far. Writing the filtering logic now, about halfway done. These micro updates do 2 things. 1, they show progress. Even if you're stuck, still debugging edge case with shipped orders maybe is better than silence. 2, they give people something to report upwards. Your manager can tell their manager, marketing can tell executives, everyone feels in control. This has a long-term payoff. You become known as someone who handles pressure well. Not just technically, but strategically. The person who fixes things and keeps everyone calm is the person who gets pulled into the next big project. Updates create trust. Silence creates fear. Choose trust. Back to that product release incident I mentioned at the start. Started scope. We froze the list of affected orders before touching anything. State filtering. Some had already shipped. We logged those and handled them separately. Idempotence. The script crashed twice due to API timeouts. We just ran it again. No duplicate work. Auditability. Logs attached to the incident ticket. Every department can see them. Dry runs. Code 3 edge cases before we touch production. Communication. Updated the incident channel every 15 minutes and every major milestone. Nobody panicked. Total time to fix? Couple of hours. Most of that were slow API calls, not debugging. This framework turns panic into protocol. Chaos into control. This is my system to do that. Next time production breaks, you'll know exactly what to do. or at least how to do it. Don't forget to subscribe and leave a like. Thanks for watching, see you next time!